guys, and today we will be talking about summation of series. Summation means adding up terms. Summation of series means adding up terms that are related to each other. You can't be adding up arbitrary terms that come up into your mind such as 1 million, 2 million, 1, 2, 3. No, they must be terms that are related to each other. So in fact, let's take a look at it. So you consider the following. So I said it was related, so you must introduce a general term. And let this general term be UR. That's the standard that we use. We denote it as UR. So let's consider the summation of the addition from U1 up to UN. That means U1 plus U2 plus U3 up till UN. You can replace R by 1, 2, 3 until N. That's called, in plain English, that's called the summation of the general term. The summation of the general term UR from R is equal to 1 to N. That is the plain English meaning of this addition U1 plus U2 plus U3 until UN. So let me write that down. From R is equal to 1 to R is equal to N. It is for this specific summation, all right? In other words, the summation from U1 to UN. In some questions, they will ask you to sum from R is equal to 5 to 10. That's also summation. Also, now let's look at a new notation, U1 plus U2 until UN. So this new notation is being used, and that is the sigma notation. Sigma means summing. So sigma UR, R is equal to 1 to N. So let's take a look at how this is derived. So UR is the general term. I said they must be related to each other. So the general term is a summation. We are summing the general term from R is equal to 1. And that is the beginning of this series. That's R is equal to 1. And the top term is N. That is the final term that you're going to sum up to and including. So if you substitute N in the general term, it becomes UN. And that is exactly what you get at the end. By the way, sigma is the Greek letter, and that implies sum. So now let's take a look at some rules of summation that are very important when tackling questions. So I think there are 4 or 5. So let's start with the first one. So the first one is the summation of two general terms, sigma UR plus VR, R is equal to 1 to N. So basically you can split the summation as sigma UR from 1 to N plus sigma VR from 1 to N. That's the first rule, and that's kind of obvious. Now the second one is a summation of K times the general term from R is equal to 1 to N. So it's simple. You can just take out K as the common factor because K is common to every term. And that is still valid. So K times sigma UR, R is equal to 1 to N. So the third one is a summation of a single term. It's not the general term, it's just any term, like 1, 2, anything, from R is equal to 1 to N. That is, you take the upper limit N minus the lower limit 1 plus 1. You just add 1 times the common factor, K, common scalar, K. So that's NK. So let's look at an example just to identify what this actually means. So take a look at this. Sigma lambda. I said lambda can be any scalar, anything you can have. Any term independent of R. So R is equal to A to B. That's B minus A plus 1 times lambda. Simple. All right. Now let's look at some standard results that you must study in order to answer these questions. These results can be derived quite easily, but let's quickly discuss what they mean. So the first one is sigma r is at 1 to n. So that is just adding up the counting numbers, 1 plus 2 plus 3 plus 4 until n. Remember, this must start from r is equal to 1. That is very important. It's vital. Otherwise, this result won't hold. And that is equal to n by 2 into n plus 1. Alright, the second one. And that is sigma r squared. R is equal to 1 to n. That is taking the sum of the squares. 1 squared plus 2 squared plus 3 squared until n squared. Again, I emphasize that it's quite important that it must begin from 1 until n. And that is equal to n by 6 into n plus 1 into 2n plus 1. If it does not begin with r is equal to 1, you can modify that so that you can get in terms of, you can get a summation which starts from r is equal to 1 to n or anything. Third one is sigma r cubed r is equal to 1 to n. That is 1 cubed plus 2 cubed plus 3 cubed until n cubed. Plus dot 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 plus n cubed, and that is equal to n squared by 4 into n plus 1 whole thing squared. So again, recap. Sigma r is equal to 1 to n is n by 2 into n plus 1. Keep in mind, it's from r is equal to 1 to n. That's extremely important. And the second one, sigma r squared r is equal to 1 to n by 6 into n plus 1 into 2n plus 1, and sigma r cubed r is equal to 1 to n is n squared by 4 into n plus 1 whole thing squared. A simple trick to remember sigma r cubed r is equal to 1 to n is just to square the result for sigma r is equal to 1 to n. Simple trick, just to keep in mind these three results. Just square the result for the summation of r is equal to 1 to n. So now let's look at some examples to further understand these results and the rules. So the first question, find the summation. Sigma 2r plus 3 whole thing squared. R goes from 1 to n. So this basically is you substitute 1 and then it becomes 2r 2 plus 3 squared, and then 2 into 2 plus 3 squared, and so on and so forth. So let's expand this. So if we expand that, it becomes 4r squared plus 12r plus 9. And now let's use a rule. Actually, let's use the first rule, the summation of two general terms. Sigma ur plus vr r is equal to 1 to n. So you can take the summation individually. That's what we are going to do here. So let's apply that here. So we can take summation of 4r squared separately, summation of 12r separately, summation of 9 separately. All three must be from r is equal to 1 to n. From 1 to n. Now let's further simplify this. Remember that I talked about a rule where you can take the common factor out from a summation, that is sigma k times ur, r goes from 1 to n, you can take that k out because it's common to all the terms in the summation. So that's equal to k times sigma ur, r is equal to 1 to n. So let's apply that to our simplified result. It's not actually simplified, but let's apply it there. So you can take the common 4 out from the first term. So it becomes 4 times the summation of sigma r squared, r is equal to 1 to n, plus 12 times sigma r is equal to 1 to n, plus sigma 9 r is equal to 1 to n. It's completely independent of r. That means like adding 9 plus 9 plus 9 plus 9 plus 9 n times. So now let's substitute the results that we achieved there up on top. So if we substitute sigma r squared r is equal to 1 to n, that's n by 6 into n plus 1 into 2n plus 1. bracket and 12 times the summation of sigma r is equal to 1 to n, that is n by 2 into n plus 1. And the last one, I said the summation of a scalar r is equal to a to b is b minus a plus 1 times the scalar, right? So let's take a look at that. It's completely independent of r. So using that result I talked about, that's the third result, the rule, sorry. So sigma k r is equal to 1 to n, that's the upper limit minus the lower limit plus 1 times the scalar k. So that's k. So simply here 9 minus 1 plus 1 is obviously 9. N minus 1 plus 1 times 9. So simplify that and you can see that sigma 2r plus 3 whole thing squared, as r goes from 1 to n, is the following result, and that is the summation that we have achieved. That's what we were told to find. That's n by 3, 4n squared plus 24n plus 47. So thank you for watching and see you in the next video.